Okay, so this is what you guys did yesterday on the test. Show that the line segment joining this and this is a chord of a circle defined by this. So in other words, show that these 2 points are on the circle. In chapter 2, I will give you this hint. In chapter 3, I will not give you the hint. And so what do you have to do? Well, you guys proved it. So one way to prove it is I can sub in this point into this circle equation. And then you can see that left side equals right side. That means, yep, this point is on the circle. Same thing here. If I put this point in this equation and sub it in, left side equals right side. Yep, this point is also on the circle. So there you go. 3 marks just like that. Can anybody tell me another way of how I can prove that these 2 points are on the circle? There's actually 2 ways. This is one way. What's another way? Anyone? Yeah?
Calculate the distance from each point to the center.
Perfect. And what is the center of the circle based on this equation? 0, 0. So my distance, if I use the distance formula to calculate the distance from this point to center, which is 0, 0. Okay, it should have the same distance from this point to this the origin to the point. And so if I calculate the distance, both of them should give me root 10 as the length. And so that I can also say it's that means these 2 points are on the circle. Okay. So now determine the equation of the right bisector of the chord AB. So to find the right bisector, first you have to find the slope of this line. So using the slope formula, I get 1 over 2. Now I'm asking for the right bisector. That means I need to do the negative reciprocal to get this line, which is my right bisector. And when I do the negative reciprocal, I get negative 2. Find the midpoint of this line, which is negative 1, 2. So now I can use the negative 2, the negative 1 and 2, sub it into y equals mx plus b, and I get 0. So my equation is y equals negative 2x. Now, what's my y-intercept here in this equation? Yep, 0. When I take a look at my graph, I know this is my right bisector. Where does it cross? What is my y-intercept here? 0. So I marked the morning class. Most of them, they got either 9 out of 10 or 10 out of 10. The people that got 9 out of 10 was because they wrote negative 2x plus like 2.5 or minus 5 over 2, something like that. They added something here. But if you graph it, it doesn't make sense. It doesn't match up. So make sure you look at the big picture. You know that it should go through here, which is 0, 0. So your equation should have a y-intercept of 0. If it doesn't, that's when you want to check your work. Especially since number 3 says that show your line goes through the center of the circle 0, 0. Okay? It's like a big hint that, yeah, it should. So there were, again, a couple of different ways you could show this. One, sub in the 0.00 into this equation. Okay, left side equals right side. Therefore, my equation is 0. The center of my circle is 0, 0. Right? You could do x-intercept, y-intercept. Let x be 0, let y be 0, and you'll also get 0, 0 when you use this equation. So a couple of different ways how you could show this. Even if you don't show it mathematically like this, you can explain it in words as well. Okay. And then lastly, what can you conclude about the right bisector and chord of any circle? Is that the right bisector of any chord will always go through the center. Okay. Just want to show it doesn't have to be the origin. So for example, if I have this right here, I can have a circle over here, my center over here. Okay, notice it's not at 0, 0. It's somewhere like in the first quadrant. But if I draw let's say something like this. Okay, these 2 points. Let's say I have this chord. Well, I know that if I have the the right bisector of this will also go through this point. But what we have right here is just one example. Is this one example enough for us to actually prove this property? No, it's just one example. So I just want to show you guys how we could actually prove it. All right. Just like number 1, we said that if those are 2 points on the circle, then that means these two radius are the same length. Oh, let me erase this a little. What type of triangle is this? Yep. Isosceles. So based on the definition of a right bisector means midpoint and then 90-degree up. Right? So at the midpoint, 90-degree up. Since this is an isosceles triangle, when you draw your midpoint and then straight up, it will definitely go to the one of your vertex. Okay, and so that's why your right bisector will always go through the center of the circle. Okay, so this is a proof based on the definition of a right bisector, a triangle property inside a circle. Okay, so I thought that was pretty neat. Okay, so this is the kind of proof that we're doing in chapter 3. Okay, so if you did well in chapter 2, that's great. All right, you're gonna see the same thing in chapter 3. If you didn't do well, okay, don't think, oh, I flunked that test. I'll just catch up on the next one. You need to still know it. You need to learn it. Don't forget it. Don't brainwash yourself. You need to apply the same idea to chapter 3. Okay, hi.
I'm late. I have to use the bathroom.
Okay, so that was the test. Now I'm gonna do. Okay. Okay, so good. Okay, so we tried to hold it up with a pencil, and Mohammed, you were saying you were trying to look for the middle of the triangle. Now, where exactly is the middle? Is it over here, over here, over here, over here? Like, how do I know exactly where? Using what we learned. All right, so let's see. How long is this line right here? This line is about 6.8. What's half of 6.8? Sorry? 3.4. So this is my midpoint right here. From my midpoint, I'm gonna connect it to the vertice on the opposite side. What is this line?
Wait, did the first person? Wait, can we have a competition to see who can hold their triangle up the longest while it's crunched?
Oh, we did that already. So now I'm continuing. No. So I'm continuing with the lesson right now. What is this line that I just drew? The middle? Median. Come on, guys. We just had a whole test on this. You didn't call it the middle line. Median. Let's do it the same thing on this side. This is 8.6. Again, wow, what are the odds? 8.6, half of it, 3.3. Wait, no. This is 4.3. Sorry, 4.3. Okay, so that's the midpoint. I'm going to connect it to the corner right here. Okay, last one. This one right here. This line is 10. So half of 10? 5. So that's my midpoint. And I'm going to draw it to my vertice. Oh, guess what? All three lines, all three medians connect at this one point. Look what I'm going to do now. What? Wait. I can't fail this. It worked. It worked for 2 seconds there. Ta-da! And it can spin too. Yay! Thank you. Yes. So, anyone know what this point is called where three medians meet? When all three meet. Oh, you know?
Is it like the orthocenter or something?
You're close. That's next week's lesson. Centroid. Good job. It's called the centroid. Alright, that's how you spell centroid. Okay, so on your next test, you might get some definition questions again. When the point where all three medians meet, it is called centroid. Okay, there's actually a property with centroid as well. If I say that this length right here is 2 centimeters, how long do you think this length is? What does it look like? 4. That's right. And it's not a fluke. It is a property. What's the ratio between this shorter line and the longer line? Yep.
1 to 2.
1 to 2 ratio. So this is 1 to 2 ratio. So similarly, if I tell you that this length right here is 9 centimeters, if I tell you the longer side is 9, how long is this? Remember, it's 1 to 2 ratio. What's half of 9? 4.5. So that means this side is 4.5. Okay. You can think of it as, since it's 1 to 2 ratio, you can think of it as breaking the line into 3 parts. 1 part, 2 parts, 3 parts. 1, 2, 3, like this. Okay. Let's say this whole line. If I tell you this whole line right here is 18 centimeters, how long is the short side?
9.
Daniel?
9 centimeters.
The whole thing is 18. So remember, 1 to 2 ratio means you have to divide it into 3 parts. 1 part, 2 parts, 3 parts. So each part is 6. So the short side is 6, and the long side is 12. Okay. So I could give you the whole length and tell you to find me the length of this. I could tell you the short length and ask you to find me the length of the long side, or I could give you the long side and tell you to find me the short side. So because of the 1 to 2 ratio, I just need to tell you one dimension, and you should be able to tell me the length of everything. Okay. Sure. So let me draw another triangle. Let's say this triangle right here. Okay. So this triangle. Right. So let's say this is my centroid. Right. So the whole length. Let's say my whole length is 27 centimeters. Okay, so this whole length right here is 27. I know that this has a 1 to 2 ratio, the short side to the centroid and the centroid to the vertex. Okay. In other words, so how many parts in total is there? 3 parts. Yeah, so there's 3 parts. So what's 27 divided by 3? 9. That means each of these sections is 9. 9 centimeters here, 9 centimeters here, 9 centimeters here. So then that means the short side is 9. From my midpoint to my centroid is 9 centimeters. And from my centroid to the vertice, it's 18 centimeters. Yeah. I think this is a better picture. That's why. I think this is a better picture. Okay. We're gonna do some practice on this as well. So this leads us to today's lesson. I have the handout for you guys. 1, 2, 3, 4, 5, 6, 7. By the way, don't come to school tomorrow.
Yeah, I know. There's no school tomorrow.
Yeah, I hate it. So if you show up at school at 9 o'clock, you'll be turned away. There's no school. He hate it.
We're gonna do it with us.
And also,
I'm actually looking like it.
and also, what's on Monday? Thanksgiving. So also, don't come to school on Monday. It's Thanksgiving.
No, I didn't.
You guys are talking about shopping already? Okay. So, yep. Oh, sorry, you didn't get one? Here you go. You're welcome. Okay, so why do we need to know about centroid? What's so special about centroid? Well, in a real life situation, A.Y. Jackson is located at 5'6". A daycare is located at -3.4, and a senior's home is located at 1, -2. Where do you think the city should put that fire station? In the middle. Although my morning class said probably beside the senior home because they are careless. That's what they said. Okay. And then I also argued that, kids like to play with fire, so maybe closer to the daycare. But then school, there's so many people at school, so then you need the fire station near a school as well. So, exactly. So we need to put it in the middle. And in the middle of all three is called which point? Centroid. Yes. So 1, 2, 3, 4, 5, 6. Okay. So this is W. -3, 4. -3. 1, 2, 3, 4. Right here. Which is D. And then senior home, 1, -2. Which is right here. S. Alright, so let's connect these. Okay. Alright, so based on the graph, it would be like around right here. But obviously we want exact location because otherwise those seniors are going to complain that it's an extra meter away from them. Okay, so first off, determine the midpoint and draw all three medians on the grid. So we know how to do midpoint. So midpoint between point D and W. Okay.
Which is D and which is
Yeah. Oh, by the way, what we're trying to do here is we're trying to solve for where that centroid is by finding the equations of the medians. That's what we're trying to do. We're basically combining what we learned in chapter 1 with chapter 2.
Can you find it just from one median line? You get the distance and divide by 2.
Oh, good thinking there. We're gonna get to that. All right, I like that. I like that thinking. It's true. Okay, so midpoint between D and W. So let me just get my.
You do -3 plus 5.
Where did I put my?
And then you do 4 plus 6. Divide each of them by 2.
Yeah. I'm just trying to find out where did I put my hand up so that I could do it quicker. Okay, I don't know where I put it, so it doesn't matter. Okay, so DW. So x1 plus x2 divided by 2.
It equals the 2 divided by 2.
1 divided by 2 over 2. So
equals equals 10 divided by 2.
Yeah, so 2 divided by 2 is 1, and 10 divided by 2, 5. So my vertex is right, my midpoint is right here at 1, 5. Now I have to connect it.
Wait, didn't you say 1, 5? That's one. Oh, that is.
Okay, what type of line is my median? What type of line is this?
Directly to
Vertical line. So can I find out what is the equation of vertical line? Y equals or x equals?
you do the.
So what is this equation?
You divide the x's by you minus the x's from each other, minus the y's from each other, you minus the x's from each other, then you divide them each by each other. The y by the x's after you minus each other.
Okay, but in this case, we can just tell that this median has an equation of x equals 1. So that's my first equation. All right. Technically, based on what Muhammad said, I could find the distance of this line and then divide it by 3 and then figure out where it should be. But problem is, how do you know if your centroid is like the first half or the 1/3 or the 2/3? So that's the part that is there's a better way. Okay, so let's try to find this. Let's try to find this median. So let's find the midpoint between DS. Midpoint between DS.
The midpoint is 1.5.
Okay, we'll see. Between DS. So x1 plus x2 divided by 2, y1 plus y2 divided by 2. Okay. So -3 plus 1, -2. -2 divided by 2 is -1. And then 2 divided by 2, you get 1. So -1, 1. Okay. So this is my midpoint of the second line. Right here. Now I can draw this. Okay. So now I can clearly see where my centroid is. It's going to be right here. This is going to be...
Wait, where am I supposed to... Oh, the midpoint to where?
Midpoint to the W. Okay. I still want to find the equation of this line first. Okay, so the slope between M and W. So you see how this is nothing new. We just did this on the test yesterday. So finding the slope between these 2 points, between that and W. So y2 minus y1 over x2 minus x1. So I get 5 over 6. Right. Now to find the equation of this line, y equals mx plus b, I'm going to use this slope and this point and plug it into y equals mx plus b. So y is 1, m is 5, 6, x is -1. So when I move it over, because this was chapter 2, so this is nothing new.
I know, but it's too fast.
Okay, I'll try to slow it down a bit.
You know what? Just keep going. I'll write it down.
Okay. Yeah. So if I'm going too fast, you can just try to follow along. I'll leave this back up afterwards. Yeah. So don't copy it yet. You can copy it after. So 1 plus 5 over 6 equals b. Because I'm trying to find the equation of this median. You guys are scaring me. You guys had a whole test on this yesterday. Okay, so
I failed the test, just so you know.
Okay, so if you calculate it, you'll get that your y-intercept is 11 over 6. If you do it on your calculator, that's about 1.8, which looks about right. Okay, it does cross your y-intercept at 1.8. Okay, so what's the equation of my second line? This black line right here. What's the equation of this line? Okay. What's the equation of this black line? Yep. That's it. Good. Okay. Now I know I have a third median to make a centroid. Do you think we need to do the third line? Okay, so how many of you say yes, we need to do all this one more time to find the third equation? How many of you say no? It's enough to show where the intersection point is.
No.
It has to be one or the other. Yeah, so no, we don't. Why we don't need the third one is because we're just trying to find the x and y value of this. So 2 unknowns, 2 equations. So all we need is 2 equations. 2 equations, 2 unknowns. So I have equation 1, I have equation 2. Using the method of graphing, substitution, or elimination, I can solve. Which method do you think is the easiest? I have my 2 equations. Substitution. This is already x equal. So I'm going to just sub x equals 1, my first equation, into the second equation right here. Right? So y equal 5, 6 times 1 plus 11 over 6. So y is 16 over 6. And I can reduce this to 8 over 3. So what is the coordinate of my centroid right here? Therefore, my centroid, remember your centroid is a coordinate, is a point. So therefore, what is the coordinate of my centroid? What's the x value? What's the y value? Jay? 1 and 8 over 3. There you go. So this combines what we did in chapter 1 and in chapter 2. Okay. However, there is a shortcut. I love shortcuts. Okay, if you didn't want to do all this right here, there is a shortcut. It ties into what Muhammad was saying. When you guys were thinking where to place the fire station, what did you guys say to place it at? In the middle. Now, if it was just between 2 points, how do you find the middle? You add the x values together and divide by 2. Now, what if you want to find a middle between 3 points then? Add the 3 together and divide by 3. So there is actually a centroid formula. Centroid formula. x1 plus x2 plus x3 divided by 3. y1 plus y2 plus y3 divided by 3. Let's see what happens. So sub in the values between D, W, and S. So -3 plus 5 plus 1 divided by 2. 4 plus 6 plus -2. Oh, sorry, divided by 3. Okay. Somebody do the math for me. So I put all the x values divided by 3, all the y values divided by 3. What's -3 plus 5?
2.
Plus 1?
3.
3 divided by 3? 1. 4 plus 6?
10.
Minus 2? Divided by 3? 8 over 3. Thank you, Ryan. Ta-da! So, yes. We could have just did this the whole time. Yeah, I just wasted 5 minutes of your life. But why did I do that? It's because I wanted to show you guys, to prove you guys why this works and how we should how to do it. All right, which leads us to the back.
On the test, will you ask us to do the centroid formula or
If I ask you for the centroid, you can just use this. When will I ask you to do all this? When I ask this. Yes. Circumcenter. What is the circumcenter? What do you think? It clearly says this on the paper, but yeah, what do you think the circumcenter represent? Yep, Nikki?
the point of intersection of two bisections in a triangle?
Right. Well, how did you guess that? Okay, so keep that. Remember that. Remember. People always mix up these two. Centroid is the intersection point of the 3 medians. Circumcenter is the intersection point of 3 right bisectors. All right, so I know both words starts with a C, but there are 2 different words. People mix those up. So make sure you know which is which. On the test, it makes a big difference. If I ask for the circumcenter and you give me just that 2 lines and say this is the centroid, you didn't answer the question. Okay, so let's try this one. This one, sorry, there's no shortcut formula. So we have to do the way that we just did. So 4, 4, 8, 0, 5, 6, 7, 8. Okay, so A, B. A, B, O, A, and B. So this is O. So I have this triangle right here. Okay. And by the way, when I do my lessons, notice I ask you guys so much questions. I sometimes I even ask like the really easy questions like what's 5 plus 5 and stuff. I want everybody to be able to participate. So some people are really good at participating harder questions. Some people still want to participate but are not as strong. So there's something for everybody to participate in. Alright, so we drew this. Determine the equation of the 3 right bisector. Okay, so the easiest one, I would say it has to be this one. So the right bisector of this line is a horizontal line. So where's my midpoint? Where does it look like my midpoint is? Yep.
4, 0.
4, 0, right? So for my first equation, I know my midpoint is at 4, 0. It's a horizontal line, so my right bisector is a vertical line. What is the equation of this vertical line? Rosie? Oh, sorry. I thought your hand was up. So what's the equation of this line? Yeah, x equals 4. Just like the first equation when we had x equals 1, vertical line has the equation x equals 4. All right. Second equation. Oh, actually, let me do black. Second equation. Let's do between AB. Midpoint between AB. X1 plus x2 divided by 2, y1 plus y2 divided by 2. So you get 12 over 2, 4 over 2, which gives you 6 and 2. 6, 2, right here. Okay. That's my midpoint right here. Am I going to draw a line to the O? What am I? That's because if I drew that, I did median. I don't want median. I want right bisector. I want a line that goes somewhere like this. Let me zoom this in a little. Okay, I want that. I want my bisector. So using what we know, slope between AB. So y2 minus y1 over x2 minus x1. So I get 4 over negative 4, which gives me negative 1. Right? That's the slope of AB. So what's the slope of the perpendicular line? If the slope of this line is negative 1, slope of the black line is positive 1. Good. Negative reciprocal. Okay. So now using this point and this slope, I can sub it into y equals mx plus b. So 2 equal 1 times 6 plus b. 2 equals 6 plus b. When you move it over, you get negative 4. So what's the equation of this line, the black line? What's the equation of this black line? I have my slope. I have my y-intercept. Rosie? Perfect. Okay. So what did we just do? We found two equations. We found the red line equation. We found the black line equation. And we only need 2 lines in order to solve for the intersection point. So again, I'm going to sub in my first equation into my second equation here, right here. So 4 minus 4 gives you 0. All right, so I got this 4 from here, my first equation. My first equation here is x equals 4, so I subbed it into here, replaced the x with a 4, so 4 minus 4 equals 0. So what's my circumcenter point? Therefore, my circumcenter is located at Nice and loud. 40. Right here. So my circumcenter is at 40. Okay. So that's why I showed it twice, because if I just did this one example, I would have shown it you guys to just one time. So I wanted to show it twice so you guys know how to do it. Okay. Further find that this point satisfied all three equations by subbing it into each. So this point right here, if I sub it into my equation, yeah, x equals 4. That's right. If I sub this point into this equation, I sub in 4 here, 4 minus 4, I get 0. So yeah, it means that that's how you fruitify. You sub your circumcenter point into each of your equations to see if its left side equals right side. Okay, any question? Okay, so it does take practice because it's, but honestly, it's nothing new. Solving equations, you did that in chapter 1. Finding equations of median and right bisectors, you did that in chapter 2. So now you're just combining your two concepts together. Okay, and the good thing is, as I said, you don't have to find all 3 lines. You can just do 2 lines and it's enough. Okay, when do you think you need to do all 3 lines? All right, in grade 12, when you do calculus and vectors. Because vectors is in 3D space, so you actually have an X, Y, and a Z. That's when you have to do all 3. All right, but for now, grade 10, you only have to deal with 2, so enjoy the time now. Okay, so for homework tonight, I know this has been a long lesson. Actually, you know what? You have half an hour. I know it's long weekend. I don't want you guys to do too much homework. So I'm only giving you guys 2 questions. Yay! See how much I love you guys? One second. Let me just tell you guys what the homework is. So chapter 3, what we just did was properties of triangle. Okay. Chapter 3, properties of triangle. We just did the first 2, and then the homework is just these 2 questions right here. Exact same format, just different numbers. All right. If you finish it in class, then you can enjoy your long weekend. No homework. All right, let's do that. You have plenty of time, 25 minutes. Okay.